A 75 kilogram skier is going down a hill that's 15 meters high. And he starts to slow down at the bottom of the hill because he needs to in order to stop before he gets to the ski lift. We're going to assume that the hill part itself is frictionless and that the flat ground, when the skier gets to here, exerts a 450 Newton friction force on the skier. We want to know how far the skier slides before he will come to rest or stop. So we want to find out this distance, d. Well, we start with conservation of energy because we know a whole bunch about the skier when he's at the top of the hill, and we don't know anything about him when he's down here at the bottom. So from here, we are going to be able to cancel things in our conservation of energy equation that don't belong. So initially, does the skier have gravitational potential energy? Absolutely, he's at the top of this 15-meter hill, so we're going to leave potential energy. But he is not moving, so he does not have any initial kinetic energy starts from rest. Finally, when he's down here on the flat, does he have any more gravitational potential energy? No. So we can cancel that out. Obviously, there's no springs or bungee cords, so no potential energy from that. Is he moving anymore? No. We want to know how far he goes until he stops. So no kinetic energy. So friction took all the energy out of this problem. So on the right side, we're just left with thermal energy. From here, we can write down our equations for potential energy due to gravity, which is mg times h. And that's going to equal over here on this side the thermal energy, which is the force of friction times the distance that the skier slides, d. Now you might say, wait, the work equation is F times cosine theta d, but there's no angle here. There's no angle to worry about. The skier is sliding to the right, and the force is moving along the same axis, is all along the x, so there's no angle, so we don't have to worry about it. Now we are trying to solve for the d, so I'm going to divide by the friction. So on this left side, I've got m times g times h all over the force of friction. And that will tell me how far the skier slides. I'm just going to plug in my numbers. The mass of the skier is 75 kilograms. G is always 9.8 meters per second squared. The h is given in the problem at 15 meters. And we are dividing all of that by the force of friction, which is 450 newtons. And when I plug that into my calculator, I know that the skier travels 24.5 meters before coming to a stop.